In this series and sequence question, we are first given that the summation of UR is equal to 1 minus n over n plus 1 factorial. And in part 1 of the question, we are supposed to find the expression for UN. And one of the ways that we can try to relate this to what we have learned in our series and sequences in APGP is maybe to just take a look at this summation using another notation. And that notation will be Sn. So Sn is going to be the sum of the first n terms, right? So it will be U1 plus U2 plus U3 all the way until Un, which is actually equivalent to this. So as I'm going to let Sn be equal to this, let me write it down. Sum from r is equal to 1 to n of Ur, which is also going to be 1 minus n over n plus 1 factorial. Okay, it is an optional step, but it is something that we can do so that our solution becomes something that we tend to get a bit more used to. Because once we see this Sn, then Un will just simply be Sn minus 1. So if Sn is this, let me write it down first. So it will be 1 minus n over n plus 1 factorial. Then Sn minus 1 will be replacing all these n's here by n minus 1. So it is going to be equal to 1 minus, replacing this n by n minus 1, then replacing this n here by n minus 1, n minus 1, then plus 1 factorial. Okay, let's try to simplify this, and according to what the question requires, we are supposed to express our answer in a single algebraic fraction. So it is going to be 1 minus 1, that will be 0. And 1 minus minus become plus. Let me write this as the first term. The numerator is going to be n minus 1. And the denominator is n factorial. Minus away this, which is going to be n over n plus 1 factorial. Okay, we are going to combine this into one single expression. And making use of the fact that 9 factorial is the same as 9 times of 8 factorial, we also can tell that based on this. Okay, we can also tell that n plus 1 factorial is just simply going to be n plus 1 multiplied by n factorial. So based on that, what we are going to do is we're going to multiply the numerator and the denominator of this by n plus 1. So it will be n plus 1 here, and the denominator will be n plus 1, then n factorial minus n over n plus 1 factorial. What is our purpose? Our purpose is to create the common denominator, because this, according to what we have just discussed, is going to be n plus 1 factorial. So in the numerator, we have a n squared minus 1 squared. The denominator is going to be n plus 1 factorial. Minus here will be n over n plus 1 factorial. So my final answer is, in one single algebraic fraction, it will be n squared minus n, then minus 1 over n plus 1 factorial. Okay, this is part 1 of the question. And in part 2, we are supposed to show that the summation of this, okay, it is less than 1 over 30. I don't think it is immediately apparent to everyone, right, how we can immediately show that the summation from 5 all the way until n is going to be less than 1 over 30. But let's at least try to evaluate this first. Summing from r is equal to 1 all the way until, summing from r is equal to 5 all the way until n of ur. And this is going to be us summing from r is equal to 1 all the way until n of ur, minus away sum r is equal to 1 to 4 of ur. Okay, if we were to sum from the first term to the nth term, minus away summing from the first term to the fourth term, we will be left with the fifth term all the way until the nth term being summed together. So this is, I'm going to just make use of this. So this is going to be 1 minus n over n plus 1 factorial. Minus away this. This is going to be 1 minus 4 over 4 plus 1 factorial. And 1 minus 1, then plus this. This, we are going to be getting it as a 1 over 30. Then minus n over n plus 1 factorial. I think now it is way more obvious to us why this is going to be less than 30. I mean, why this is going to be less than 1 over 30. Okay, we can already see the sign of 1 over 30 here. So I just need to give a quick explanation, a quick algebraic explanation. I'll say something that is like this. for n to be bigger or equal to 5. Okay, this is given to us by the question here. Okay, we are analyzing this for n to be bigger or equal to 5. So for n to be bigger or equal to 5, we know that this expression here, which is n over n plus 1 factorial, has to be a positive number, which means that if I were to multiply negative to this, it will be negative of n over n plus 1 factorial, should be a number that is less than 0. Adding 1 over 30 on both the left and the right hand side, it will be this, minus n over n plus 1 factorial. Adding 1 over 30 over the right hand side, it is going to be 0 plus 1 over 30, which is going to be 1 over 30. And what is this? This is this, right? So I can then replace this by the summation from r is equal to 5 all the way until n of ur, okay, which represent this. So this is less than 1 over 30. And this is what the question requires us to show. The last part, part 3. Part 3, we want to explain why the sum of the series, this. Okay, the sum of this series is a convergent series. So the sum is this expression, and we can see that as n tends to infinity, it is going to be influencing this n over n plus 1 factorial. And if you were to be letting n becomes a very big number, we can just try out the numbers on our graphing calculator. We will be seeing that the numbers will start to converge to 0. Okay, that means if I were to let n be, for example, 10, I'll let n be equal to 11, or I'll just let n be equal to 20, and so on, right? Okay, the result will be converging to 0. So we will just say that this is going to tend to 0. And if this tends to 0, if this portion here tends to 0 as n tends to infinity, that means this entire thing will just converge to 1, which means that, therefore, the sum from r starting from 1 all the way to infinity of ur is a convergent series.